Hi, AGB students. This is Rob Jensen, your math instructor for your SAT courses. And today, this video is be going and recovering um, answer solutions to the SAT March 2019 test, Section 3 specifically. So we'll be walking through those, and I'll kind of be showing you my methods and walking you through and how I solve these types of problems or things. So let's go ahead and begin. Let's look at the very first one that we have here. We can see that what we have here is we have a linear developing question. So we have a linear equations. We see that we've got a word problem of things, and we're developing something that's a representation of that. So as we look through this is Tony spends $80 per month on public transportation things. And so we can see he spends $80 per month. And what that there is representing is our total value, because that's the amount of money that he spends, for a particular month of sorts. We can see a 10 ride pass costs $12.50. So we can see that information there. And then a single ride pass cost $1.50. So if G represents the 10 rides, so we see G represents 10 ride, and buys in a month, and T represents the number of single ride passes here, which the following best represents the relationship between G and T. So as we kind of go through this, we know that he spends 80 per month, and so looking at B, we see 80, we see 80, we 80, so B does not fit that description whatsoever. The other thing, 10 ride associated with 1250, we can see that, which is also represented with the G here and such. So 1250 G we see there. The $1.50 single pass rides with T, so we can see that being represented right there and such. So the answer choice for this one we can see is D indeed. So that is our answer choice here. Sorry, should be highlighted instead. So that is our answer choice on this one. Here, number 2, we see we have another linear equation, right? We see we have another linear equation being denoted by this. We see another word problem of sorts. So here, we're not developing it. We're actually having to solve for this. Most likely, we're given values that are representing these variables here and then having to plug them in. So this is what we call an equation word problem. Rather than having to develop it, we're just solving for it of things. So let's go in here and look and see what we got. We see T represents total take-home pay. We see that. So T is the take-home pay in dollars for first week of work, where H represents the number of hours that she's worked, the number of hours she's worked that week. And 1,000 is the sign-on bonus of things. So if Brittany's total take-home pay was $1,576, how many hours was Brittany paid her first week of work of things? So we then know there's a difference there. The 1,500, this value here is what she took home completely. So that there is the T. Okay, that's the T right here. I think so. We can just input those values. We have 15,776 is equal to 1,000 plus 18H. I think so. We're going to subtract 1,000 here. So we're going to get 576 is equal to 18H. Now we realize we don't have a calculator here, and we have to divide by 18 thing. So what we can possibly try to do. And we see the numbers, there's a spread on the numbers here, is pretty big. 18 is close to 20, right? So 18 is close to approximately 20. And we know that within 100, 20 goes into it. 20 goes into it 5 times, right? So 5 times 5, because there's 500, is going to give me 25 of sorts. And then we know 20 will go into 76. Well, probably another, we know we're overestimating a bit, so at least another 4 times, so 29. So looking at this and sort of doing an approximation, we know 16 is way too small of a number, and 55 is going to be way too big a number, and so is that. So the answer choice on this one has to be B, just using some approximation there. Number 3 here, for what we see. We have inequality here. We're developing an inequality at this moment. So much like we use procedures to solve for number 1 here, we need to do the same thing for number 3. It says a clothing store is having a sale on shirts and pants. During the sale, the cost of each shirt is $15. So each shirt is $15, and the cost of each pair of pants is $25. Jeff can spend at most, it says at most, so we can't spend no more than $120. That means you don't have any more money in your pocket or a credit card to use or anything. So if Jeff buys S shirts and P pairs of pants, which of the following must be true? Well, we can kind of go through here because we know we can't spend no more than 120. So that is less than or equal to 120. That's good. That is showing that it's greater than or equal to, so it can't be that one. That one looks good. Can't be that one. So this is a classic divide and conquer question. So now we're just trying to match up the variable to the proper dollar. So we see shirt here in 15, so 15s, where here we have 25s, so no, not it. So we see on this one, particular one, A is the answer choice on this one. Okay, so let's look at number 4, what we have here. It says, what is the solution to negative 3 times x minus 5 equals negative 2x? So here, this is just a linear equation. We've got a lot of linears we're seeing right now. We're seeing in these first ones, linear, inequality of sorts, but it's kind of treated as a linear such. But so we need to make sure that we distribute our terms first. So that's the very first thing here. And so in my distribution, I'm going to have negative 3x plus 15. Make sure we take care of those negatives. Minus 2, that's minus 2x. Make sure I carry that. Plus 4. Now I don't want to have, I'm always trying to move things where I don't have a negative x to work with. So I want to move this over here, and I want to add 3x. And then I want to move this segment over here, and I want to minus 4. So as a result, as you can see, I'm going to get positive 14, positive 11, I'm sorry, positive 11 equals x of sorts. And there, that's all we need to do. A is the answer choice there on that one. Okay, let's look at number 5 here. So number 5, we see this is a classic functions, operations questions here. We have a value of -1 that essentially that we're going to have to put into here. And so we can rewrite this expression as f of -1 equals x cubed plus 3x squared minus 6x minus 1. And what we're essentially needing to do here is wherever we see x on this one, we need to input or insert -1. Now, given that we've got this negative here, and what most students kind of where their mistakes happen to come from is that they're just not being mindful of the negative. So we know here that's going to be -1 cubed plus 3 times -1 squared minus 6 times -1 minus 1. So let's take care of these negatives here. So -1 cubed, that's going to be -1 times -1 is going to be +1. So +1 times -1 is going to be -1. So I have a remainder of, which resultant of that is -1. That's going to give me a +1 there. That's going to give me a +1. So 3 times a +1 is going to give me 3. So it's going to be +3. And I make that a little more easy recognizable. So 3 times 1 minus 6 times -1 is going to give me +6. And then you see here I have -1. So add up my terms. I see I have here I have 9, right? So I have 9, and then here I have -1 and -1, so that's going to give me -2 of things. So as a result, I'm going to have 7 as my answer of things. So you can see right there. Okay, number 6 here is kind of a unique similar triangle problem. And we know it's, I mean, we see it. It tells us that we are dealing with similar triangles of things, okay? And it says where AB, line AB and DE are corresponding sides if DE equals 2AB and the perimeter triangle is 20, what is the perimeter of triangle DEF? I think. So here we just kind of have to make up numbers. You know, one of the things that we can do is try to draw these different triangles. So let's see here. We've got let's draw my first one. And so it doesn't really matter what this will happen to look like. A, B, C things. We just know they're similar triangle. And make sure we draw one that is DE is twice as big as 2AB. So this means this one's bigger. Okay, so this one is bigger here. So we'll draw this one kind of not too perfect or anything. But you get the idea that it is going to be D, E, and F, right? So A, B, C, so A corresponds to D, B corresponds to E, C corresponds to F, and we see that here, okay? We know DE is twice as big as 2AB, so as we sort of, if we want, we can like make little notations on these sides to know that they're similar to each other of things. And we know that the perimeter of ABC is 20. What is the perimeter of triangle DEF? Well, we can just make up numbers here that largely fit what we have. I don't know. I mean, if we know the total perimeter ABC is 20, I can just say, I can say this is 4. I can say this is 7 and say this is, well, hold on, that would be, no, that can be 8, that had to be, let's say this is 9 here, okay. Okay, so if we tally these up, 4, 7, and 9, I'm going to get a perimeter of 20, just like it is telling me, right? Well, we know that DE is twice the length of AB, right? Well, if it's twice the length of AB, then that's going to have to mean this leg is 8. And remember, these are congruent triangles of things. I could do ratio and proportions. I certainly could. I don't need to do ratio and proportions, but what I understand is since they are of similar triangles, meaning that the angles are the same, that means that the lengths and the relationships between these two are the same. So if DE is twice as big as AB, that means EF has to be 14, and then DF has to be 18. So as a result of that, adding up these values, that is 8, 14 is going to give me 22, 22 plus 18 is going to give me 40, and my answer choice on this one is B. Sorry, B. Okay, number 7 here. We see just by looking at these answer choices, just by looking at them, we see that we have an exponential function, and we're having to develop it. Okay, we're developing this thing because we see that we have a word problem, and we have something in here that has to represent what's going on up here. So as we look into the problem, it says there were no jackrabbits in Australia before 1788 when 24 jackrabbits were introduced. So that is our starting point. That means if we was to sort of kind of draw this thing out here, okay, that means that my starting point here on this would be at 24. So we have some sort of exponential growth function that's doing this, okay? So we then know, looking at our answer choices, you know, because of the formatting, it has to be y equals a times x times the b, right? Well, that a there has to be 24. So looking at our answer choices, that means a is gone there. It says the population of jackrabbits had reached 10 billion. If the population had grown exponentially, this would correspond to a 16.2 increase on average in the population each year. Now, remember with the SAT, when we're talking about an increase of some type, okay, then that's above 100%. So really what that means is that we're talking about 116.2%. So the corresponding decimal, because we've got to move that over twice, has to be this one. Yeah, has to be that one, because can't be that. That's suggesting that's a 200% increase. And we're not multiplying. This one here, should have already eliminated, quite honestly, because I just sort of did not catch it looking through, but that doesn't even fit the formatting of this equation here, so that's gone. So C is the answer on this one. All right. Okay, let's look at number 8 here. What we see here is that we have some common terms, and we're summing these polynomials essentially. And so here we're adding. We see 3x to the fourth and 4x to the fourth. Since those are like bases there, we can add those. So 3x to the fourth plus 4x to the fourth is going to give me 7x to the fourth. Well, the only one that so happens to fit that is D. And so we can see D is the answer choice there, because we do not add, we only add exponents when we're multiplying. When we're adding, we just retain those same bases. Okay, number 9 here. Okay, number 9, we see that we have a function. We're doing some translation of this function of things. We see that it is a quadratic, right? That is a quadratic term. If you remember the formula that we have for vertex form of quadratics, right? So remember the vertex form is equivalent to y equals a times x minus h squared plus k. Well, in this one, we see that there is nothing there. It just says x squared. So really, if you're plotting that of things, okay, if we're plotting that, that means there's no x movement of the quadratic. So that means there's no horizontal movement and there's no vertical movement. So that means we are starting right here at 0, 0. So that one is suggesting 0, 0 as the vertex. The next one here, okay, this one here, we see that there's nothing inside the parentheses. So that still means the x value of the vertex has not moved. But however, we have the plus 3. So that means we're now shifting up 3. So that means we're going 1, 2, 3, I think. So the new vertex point is right there of sorts. Okay. So the answer choice on this one would be a translation of 3 units upward. Okay. All right. Number 10 here. So number 10, we see that we're dealing with angles and lines. We see that we've got this figure. It's not drawn to scale or anything like that. And we see the key word in this parallel. Now remember, when we see the key word that's talking about parallel of things, that should bring to your attention that there's probably z transversals in here. I can barely get that in and such. So we're looking for our z's within this. It says in the figure above, segments AE and BD are parallel if the angle BDC measures 58 degrees. So if I know that is, say, 58 degrees, right? And ACE, so that's the top of this triangle, right? That is going to be 62, right? So that is 62 degrees. So I can now derive that angle by summing these two up. So if I was to sum those two values, I know that's going to be 120 degrees. So therefore, this has to be 60 degrees, right? So it then is asking, what is the measure of CAE? So this is the one that's largely in question right here. We do not know CAE. But what I can do is I can kind of draw a line that comes off this thing, right, like this per se, and draw another line that comes off this one per se. And if I know the supplementals, that means this is 60 degrees. So then that means this has to be 120 degrees. This is an inside angle of the z. You see the z that we have here. So that means this has to be 120 because that's the outside. Therefore, this has to be 60 of things. And I can see that my answer choice is B. All right. Let's keep moving along here. Number 11 that we have here. Number 11. Okay. Let's see. So what I'm looking at here, okay, so what I see here is this is basically a ratio, I'm sorry, not a ratio, this is a rewriting algebraic expression problem. Remember, these are what we call our RAEs. And one way I know that is one, I see this formula here. Two, I see, and it says in terms of the speed of the wave, right? So in terms of, that's the key phrasing there. So we're saying S equals, and I want to be in P equals here. So let's bring it down. So S equals 3 halves P. And I want to isolate the P, right? Well, in order to do so, I need to multiply by its reciprocal. So to get rid of 3 halves, I have to make this side 1, right? So by multiplying by its reciprocal, because 3 halves times 2/3 is going to give me 6 over 6, or 1. So that just leaves that on this side. So then over this side, it's going to be 2 over 3 times S equals P, because remember 3 halves times 2/3 gives me 1. And as a result, I'm going to have P equals 2/3 times S. So the answer choice here is A. Okay, number 12, we see what we're trying to do is to plot this line and identify its equation. Well, it's a negative slope. These are all negative slopes. Oops. Okay, so don't have to worry about that. I see that my intercept here is at 1, 2, 3, 4 is at 0, 4. So looking here, that means that this is gone and this is gone because 8 is the wrong intercept. And then I need to figure out, well, how many units downward am I going of sorts? So here I can see I'm going to go down 1, 2, 3, 4. So I'm going down 4 and then see what my run is here. So you notice this says 2. Okay, so we really got to be careful with that. So that means I'm increasing in units of 2. So 2, 4, 6, 8, 10, 12. So the slope, okay, the slope is going to be the rise over the run, which is going to be negative 4 over 12, which then reduces down to negative 1/3. So therefore, my answer choice on this one is C. Okay, so yeah, just be very careful, especially when you have these things that are later in the section. This seems almost too easy to kind of be here at this spot. And that's the reason why, is because you could see these are increments and 2, which many students may fail to pick up and probably, as a result, get the wrong slope there of things. Okay, number 13. All right. So number 13, we see that we have a triangle that's inscribed into a circle. We know that the angle of the triangle corresponds with the segment of the circle of things on this one. So it says triangle FGH is inscribed in a circle if the arc FG is congruent to arc GH and the measure of G is 30. So we know that this is 30 degrees, right? And it is expressing to us that FG here, so this arc here, is congruent to GH. Well, all that means is that these angles here are the same. All right, these angles are congruent to each other. So that is then telling us, so what is the measure of arc H? Well, if essentially what we have here, this is an isosceles triangle is what we have here. So, 180 minus the 30, that's accounting for angle G there. So that's 150. And then we know that these angles are congruent, so divide by 2, so we end up getting 75. So the answer choice is C there on that one. Now, this is a very unique radical equation. And we know it's a radical equation because we see the radical, right? So we need to be in that habit of seeing that this is a radical equation here. And this is sort of unique. It has a quadratic that resides underneath it. Well, what we have to pick up on here is that we can factor that quadratic. So let me sort of rewrite this to where it's a little bit bigger here. So that's the fourth root, or the quad root, of x squared plus 8x plus 16. Well, I can then factor that into the quad root of x. Oh, sorry, don't know how that happened. Wrong button. Nope. Let me try to get rid of that. Go away. Delete. There we go. So I can rewrite this into x plus 4 squared. Now, if you recall, when we're talking about this is well, hold on. I misspoke. This is not a traditional radical equation. Really, what this is, I'm sorry, is a fractional exponent problem. This is what this is. This is, you know, it's a fractional exponent problem, not a radical. I jumped ahead there. So we know that the fractional exponent is this is the power here. The 2 is the power. The 4 is the root. We know that this is now equivalent to, so we can rewrite this expression as x plus 4, the power, which is 2, over the root, which is 4, which essentially gives us x plus 4 times the 1/2. So that's really the square root, or we could write this as the square root of x plus 4. That would be the same thing. So the answer choice on this one is D here. Definitely a little different for a fractional exponent problem. Okay, 15 here. My recommendation on this one is we're dealing with constants. We have a linear equation. We're trying to graph this thing. So why not just make up numbers? You know, it gives us some sort of relationship here. So I'm just going to say, you know, hey, I'm just going to say, you know, A equals 1 and B equals 2 here. Okay. And plug those values in. So, so rewriting the expression above, ax plus by equals b, now I know that is going to be just a is 1, so that's just going to be x plus 2y equals 2, right? Well, let's move that over because we need to put it in slope-intercept form to appropriately graph this. So this is going to be 2y equals 2 minus x. Divide by 2. So remember, we're going to use the distributed property on the right-hand side of this equation. So my final equation is going to be 1 minus 1/2 x. Well, we see that we have a positive intercept here, right? We have a positive intercept right there. Yes, that is correct, because that's 2, 2. Yes, that is correct. So therefore, it cannot be b or anything. Okay, so we have that much that we know, all right? So we know 15 cannot be b because of the negative intercept that it has. And we have negative 1/2 as its slope. These are all negative slopes. So let's count these things up and see. On this one, I can see I am going down 2 and over 2. So the slope on that one, so we see here that the m here equals 1. So that won't work there. So it's not A. C here. Let's look at C here now. So C, I'm going to go down 2. And I'm going to go over 1, 2, 3, 4. So you can actually see I'm going over 4. So that's down negative 2. So you see that the slope here is actually the m equals negative 1/2, which that is what I have over here, right? So let's just double check here. And make sure that what I have is correct, because we see this is kind of a neutral slope here, you know, going down by 1. This is has a much longer run than a rise, of course, you can see that. Where D, we're going down 2 and over 1, so that's going to be a negative m equals -2. So you can see it's a much steeper, so it doesn't matter what values we so happen to choose here. A is always going to be, if you notice, A here is always going to be less than B, which if you have a, remember, a rise over run, where you can see this is making up of, sorry, this is the A value here, and that is the B value. So A over B, which the A is always going to be negative, and A is less than B. So you're always going to have a much longer run, as you can see here, than you do of a drop and stuff. So D is wrong. C is the right answer choice. The best thing to do is make up numbers to kind of understand the relationships on those things. Okay, let's look at number 16 here. Things. 16, we see we have just a linear, so that's just going to be 2x equals 9 divided by 2, and we see we can get x equals 4.5 there. So there is your answer choice on that one. Now, number 17, what we shouldn't recognize is this is a rational equation here, and of the type that we're factoring. And so if you picked up on that, we always want to look for this bottom term into the top term. So the top term would be, when we factored it, it would be x minus 3 times. No, sorry, that's not the correct thing. That's not the correct. I need to factor out a 3 on this one, actually, I think. No, I need to factor out 11 on this one, sorry. I need to factor out 11 up top, so that gives me 11 times, which would be x minus 3. There we go. Well, I guess I could have factored out an x minus 3. X minus 3 equals x. Well, as you can see, we can now eliminate these terms, so you end up getting 11 equals x. That's your answer choice there. Okay, so what you see on the next one, we see this is a systems, but not just any systems, it's a special values one. So special values. And we know so because we see it asking for something that's other than just x or y. So when we have that, remember we want to add up these terms. We want to add up these terms. So 2x plus 3x is going to give me 5x. 3y minus y is going to be plus 2y equals 61. Well, what I noticed here on this is if we're trying to get to 100 here, I then have to multiply this by 20, right? And then 20 times 2 is going to give me 40y. So I'm multiplying this whole thing by the value of 20. So in doing so, distributing, okay. You now are going to see I now have 100x plus 40y equals 61 times 20. Well, we can do that. That's the easiest way you can do that is 61 times 10 is going to give me 610, right? And so do 61 times 10 again is going to give me 610. So add up those values because that's the same thing as saying 61 times 20. You can see I'm going to get 1220 is the answer choice there. There we go. Okay, number 19 here. This is a little bit of a different. And one thing I've always sort of tried to point out to you all is that when you see a quadratic and an equal sign, right, we know we're solving for roots, right? The unique thing here is that says 3t parentheses. That's in parentheses squared. So that means we're multiplying 3t twice. So that should read as 3t times 3t minus, and we got to distribute that. That's going to be minus 15t minus 14 equals 0. So this is when we expand here. I'm going to have 9t squared minus 15t minus 14 equals 0. Now, this is a little bit different. One thing we need to sort of recognize and understand is quite often with the SAT, they're not going to give you some crazy quadratics to factor, but I know that 9t squared can be rewritten as 3t times 3t. So that's what I want to kind of try first. And if I'm trying to get to negative 14 there, my factors can be 7 and 2. So that's a negative 15, so that means it has to be minus 7 and positive 2. So 3t times negative 7 is going to be negative 21t. So that's going to give me negative 21t, and then 2 times 3t is going to be positive 6t, which is going to give me negative 15t, which you can see that checks out from what I have right here, right? So we know this is good. So solving for this, we have 3t plus 2 equals 0, and 3t minus 7 equals 0. So here we got 3t equals 7, or t equals 7/3. Over here, this is going to be 3t equals negative 2, or t equals negative 2/3. So you can see the two answer choices we have. It says t is greater than 0 there, so this is the one that we're looking for, because you can't greater than negative, okay? And then the last question that we have here, we see it says the function h is defined above where a, b, and c are integer constants. If the zeros, remember if the zeros, that's our x-intercepts, the function are negative 5, 6, and 7, what are the values of c? Well, we can, if we just write that, if I say x equals negative 5, x equals 6, and x equals 7, I can rewrite those binomial terms to be like x minus 5 times x minus 6 times x minus 7. Well, I just want to know the constant term here. That's the only thing I want to know. It says, what is the value of c here? That's the constant term. Well, I don't have to go through and distribute everything. All I have to do is just multiply these terms together. Sorry, these terms together. So negative 5 times negative 6 is going to give me, or sorry, hold on, that should be positive 5 right there, sorry. That should be positive 5. Is going to give me negative 30. And then times the negative 30 times the negative 7 is going to give me 210. So there's my answer choice there. All right. Thank you all so much. I hope you found this to be helpful, and be looking out for section 4 next. Thanks. Bye-bye.